And the talk we are going to have today, it's about once you have your application. In this case, we will be working with a Flask application. How do you take it to production? There are many ways to do it, and we will be focusing on a containerized based one and mostly based on Kubernetes. Of course, there are many good ways to do and also not so good ways to do, and it will depend clearly on the state of your company and how are you doing it. So let's go for it. It will be very similar. Instead of Flask, you use Django or Fast API or whatever framework you want. A bit presentation about me. I'm a software engineer. I work at Canonical, and I mostly work with Python, building software operators. That is software that will manage all the software. And my background is mainly on networking. I've been working on networking protocols and then networking nodes. And after that, I've been working with backend systems. And from there, I have a great interest in DevOps, in clean code, and how to not wake up at night and things like that. So hopefully this will help. You can see how to connect with me. I will be very happy to meet some of you. So let's go very quick about the agenda. We'll first make this very quick introduction to the topic that's deploying to production. We'll create a very simple demo Flask app, and we will iterate over that. We will create a container for it, and then we will use Helm charts first. Then we will do Helm charts for the people that doesn't know about it. It's like a kind of package system for Kubernetes. Then we will go through Fly.io, that is a platform as a service. I chose Fly.io because it's a widely used one, but there are other options that we will see. And finally, we will deploy with Juju. Juju is from Canonical, the company I work on. And if you don't know Canonical, it's the company besides Ubuntu, and everything is open source, so you can use it at your home or however you want. And then we will have a conclusion that it's not really a conclusion, but a summary of what we've done. So let's go for the introduction. You have a Flask application and you want to deploy it in production. What are your options? Well, there are many of them. You can SSH, you can use Ansible or any other tool, or you can go for a containerized way of doing it. You can go the plain Kubernetes way or a bit more adapted like Helm charts. You can use a platform as a service that kind of we build a containerized system and deploy it in their infrastructure, or you can, in this case, the other options that I'm proposing is use JujuOps tooling. You can do all, well, except of course when you are using other infrastructure, you can do it locally. You can do it in premises, locally I mean in your laptop, or you can do it in the cloud. And this will be the amazing Flask application to start with, as simple as I could do it, just to show how to deploy it and not to waste much time and effort on that. And it's basically an endpoint that returns hello world. And the first step is to create a container. If you Google how to create a container for that application, you will get something very similar to it. Yesterday, I was like asking ChatGPT, and it was basically the same answer, which is not bad, but it will work. But you have to take into account several things, and it's not really for production, but it will work. The first one is which base image you want, how do you want to do it. The second point of attention is that you are copying everything from your current directory to the image, so it will probably be bloated. You could even leak secrets. And the third problem is that you are running Flask in developer mode, which is not a good way to run it in production. There are more issues, but we will not work over them. Besides, there are other things that this solution doesn't take into account, like metrics, observability, all of those kind of things. And a very quick digression about what we have with that Docker file, and that was creating a Docker image. When we really are referring to a Docker image, what we really want to refer to is an OCI image. And OCI are specifications from the Linux Foundation project, and there are like 3 of them for runtime, how the images are run, for the image spec, how the image is built, and the distribution spec, or how the registries are made. Containers are shown as one virtualization technology, and this kind of OCI containers are one of them specific. And there are the thing about this specification is that there are many tools, both to build the containers and to work with them, to run them, like Docker, Podman, Buildash, Copio, and many others. And the approach I'm going to take now to make it a bit more production ready is to use another tool to build the container. And we are going to use a tool that we are building in my team that's named Rockcraft. And the thing it will done, it will inspect the application and create a production ready container. So you can run these commands in any distribution that support Snap, which is most of them. Where all the videos you will see are running in Ubuntu. You can run it in a virtual machine. And so let's go for it. You have a QR there that basically will follow a tutorial very similar to what's done in here. And it's really nice because you can run it from Windows or Mac just with a virtual machine. So let's go to create the OCI image, the Docker image. First, we have the requirements file with just our only requirement. We'll also have the application that we've seen before. We can test that it runs correctly. That's how the application was run in the initial Docker file, so not production ready. But anyway, we can see that's clearly working and returning the payload we created. And as said, the tool that we are going to use is Rockcraft. It will be like 2 steps. One that will generate the Rockcraft YAML file, kind of the Docker file. And then with that, we'll pack it and it will create the OCI image. The main difference between Rockcraft and Docker file is that Docker file is imperative and Rockcraft is declarative. So you define what you want to have, not really the steps you have. The Rockcraft YAML it will generate has already inspected our application and it will be trivial, but it can be customized. And at that point, we will pack it and we will have our Docker image. And just to prove that this is a kind of Docker image, I'm like mixing the terms continuously. And we have like the file it has generated that has this target zipped file, that's the .proc. But we can use another utility for OCI containers and we can use Scopio to put that image to the Docker daemon. And when it's there, we can see that we can list it. It's a perfectly valid Docker image, with the difference that it will create it with the other tools and it's production ready. And just the last part, we can run the container and curl, and of course, it should work. So now we have just stepping back. We've created our Docker image and we are going for the main topic of the presentation, that's deploying it to Helm. Helm is a package system for Kubernetes and Kubernetes is an orchestrator for containers. So it looks like very complex, but to install it in your laptop, for example, a Kubernetes distribution, you can use, for example, Microgates. That is a very simple Kubernetes distribution and that you can also scale that both for locally and for a real production with several nodes. The thing about Microgates is that it already has installed Helm and it has all the tools that we need. That basically is an ingress for this very simple application. So I don't know if it's stopped now. No, it's not. So basically, we had our image, our Docker image before, but it was in the Docker daemon, not in a registry. You have to put it in a OCI registry, so it can be taken from, it can be pulled from Kubernetes. And once we have our OCI image in the registry, the next step is just to create the Helm chart. Helm charts are, that is a wrapper about the Kubernetes application. It's relatively straightforward and very coupled to Kubernetes. So a chart YAML file will define that's the package of the chart, and then we'll have the values that will be interpolated into the Kubernetes manifests. In this case, basically the number of containers we will launch, number of pods, and where is the image and the tag, and not much more. And for this kind of application, that's very simple and as simple as I can do to do 3 deployments in 20 minutes. We'll have a deployment that will deploy 3 pods over a replica set, and it will take all those values from the values YAML file. But clearly at this point, if we deploy this to Kubernetes, it will just have like those 3 pods on its own. So we'll need something more, and it's a Kubernetes service. For those who haven't worked much with Kubernetes, a service is kind of a load balancer. So basically, request will come to the service, and they will be dispatched to one of the pods, and kind of in a load balancer way. However, the service is not exposed outside of the Kubernetes cluster, so we need something to get to those pods containers inside, and that's an ingress. So basically how it will go in Kubernetes is it will go for an ingress that it will point to the service, that's basically a load balancer, and then it will go to each of the pods. And we define those 3 things with, well, we defined it for the Helm chart, using the template system. That's basically the Go system, very similar to Jinja. And once with these files, we already have a Helm chart. We could take this Helm chart and put it in a repository, and other people could use it. In our case, we will just run it, and well, after installing it, it will take a bit of time to deploy all the micro-K8s objects, and we can curl it, and of course, it will work. Going back, we have an OCI image. We put it in a registry. We created the chart, the Helm charts YAML files, and we created like the Helm chart, and we deployed, and it worked on a Kubernetes deployment. So let's go to the next way, to the next step, and it's a platform as a service that this will not run locally in your machine. It will run in the infrastructure of the platform as a service provider. As said, Fly.io is a widely used one, but there are other very nice ones. Probably you've heard about Heroku or Google App Engine. Heroku, well, I really appreciate them because they were the ones pushing for the 12-factor methodology. And let's go for it. So the idea about Fly.io, they have, I think the client is open source. They have an open source client that it will go do something similar to what we see in Rockcraft. It will inspect our application and see how to do it. So basically, we will install the client. About all the methods of doing it, well, this presentation is 20 minutes. I think it's very nice if you can do them, because it doesn't really take a lot more time, just a bit of waiting between commands. And let's say, once you have the client installed, you will do fly launch. You will go to the web page, you will register, you will insert your payment data as you are putting things into the resources. And not very long after that, you will have like 2 files. One is the fly toml file, and this will have information about your environment for your application, how it's built, and where it will be deployed. And then there will be a second file, and it's again a Docker file. And there is a bit of a trick in here in how the Fly tool created this Docker file, because let's say it inspected the image, but it created a Docker file, but it doesn't run containers. It will create a virtual machine with this Docker file. But very interesting, you will see that this Docker file is quite similar to the one we created before, so it also has the same issues. That is, it could be copying all the files that you have in your current directory, and it also runs a development server. The next step is just fly deploy, and after, well, a few minutes, I think it takes, you will see that you can curl that URL and it will work. Very interesting. There is more things. There are more things in here than in the previous thing, because the domain name was already set. You have a TLS certificate, so it has done a few things over just preparing the ingress for it. Probably this is the simplest way of deploying an application. And the last method I'm going to talk is Juju. Juju is an orchestrator for operators. So let's say it will be a bit more similar to the first one, a bit different to the second one. The idea is that, let's say, you have your workload, your container, and there will be other pieces of software that will manage your containers. So you will have like for every application another small piece of software that will be the one that handles your application, and we will see the advantages of that. The tool Chunkraf is the one that creates that software operator that manages your application. And we will not see it much, but we will see that it has some advantages. And the Juju application is just the orchestrator that you have to install in your Kubernetes cluster before. So let's go for it. First, we will change the application a bit. In this case, we will be a bit more complex, but still very simple. And what it will do now is to use Postgres. So first we need in the requirements the Postgres client. And then the application will be a bit different. The first thing you will see is that it gets from the environment variables the information it needs to connect to the database. I mean, that's the URL and the credentials. And then it has two endpoints. One just to insert one thing into a database, and the other one is just to query the amount of things that are in the database. It will be interesting because, as you can see, that database URI, the credentials and the information to connect to the database, we will not define it anywhere. Well, one thing in here, it's probably this is not how you will probably do your application. As you will need like a connection pools and things like that, but this is just to make it as simple as possible. But of course, let's say we are inserting things in one table in one database, but that database didn't exist by itself. We have to create it at some point. There are many ways of doing this in a Python application. In Flask, it's normal to use Alembic. In this case, we will just have a simple script that will create the table. In Django, for example, you will use the very nice Django migration tools. And with those three things, we already have our Flask application, a bit more complex, but nothing really very big. We will change our rockraf file, our rockraf YAML file to create the container, not very different. One thing, we can expand it and we will see really what it does. So this is what the just extension for Flask task, and you will see here what it's really doing in all the steps and how it runs. And it's very interesting that you will see that it uses Unicorn, for example. It also have a stats exporter, so you can have metrics to Prometheus. And we again have our OCI container. We will create it. And of course, we'll put it in the Kubernetes registry, in the microcades registry. And at this point, we have our new OCI image with the new application we have. We could run it with Docker, but we will have to put that information for Postgres, and we'll have to take care of the migration script. In this case, we are going to create the chunk that handles that application. It's just a Chunkraf init with a profile Flask, so it knows that's a Flask application. And again, there is a YAML file that defines how that software operator is done. And the change we need for this application is to tell it that we want to integrate with Postgres. There are lots of integrations, and we are writing a few more now. Besides this kind of databases, there are other things like, for example, you can directly integrate with COS integration. I mean, like that will deploy immediately, like all the Grafana observability stack with Loki, Grafana, and you will directly get metrics for it. So it should be like a few more commands, but we will not go that way. We again pack the CHAM. In this case, it creates information for that software operator, and at that point, we can deploy everything. The concept of Juju, similar to Kubernetes namespace, is the model that will kind of put several related applications in one place, and we can deploy the Flask CHAM, we call it, that will have the software operator and will start the workload. We will deploy a database. This will really deploy a database in Kubernetes. We will integrate both of them, and same for the engine X integrator that will create an ingress like in Kubernetes. Once we wait a bit so everything works together, at some point the operators will talk between themselves. They will create the database and they will pass the credentials. They will run the migrate commands, and at some point our application will be there, and it will have like an ingress resource in Kubernetes that can be queried and will get the information. So I think at that point we curl the visitor endpoints. So there are 0, and once we do our request, the next time we query the visitor's endpoint, it will require apply 1, and so on. So just a conclusion, well, again, not really a conclusion. What we've done is we created an OCI image. First, we have the Docker file. We use another tool that created more or less it in a production way from directly. We're having to worry about that. We will deploy it with Helm charts. Helm charts expose all the Kubernetes objects, and you can do whatever you want with that. That's in some parts really nice because you can use all the Kubernetes functionality, but you have to be aware that you know it. The second part, time we've deployed it with Fly.io. That's a bit different. It's a proprietary platform as a service, probably the easiest one to deploy and quite quick. And the Docker file they provided to us, it's not very production ready. And finally, we've deployed it with Juju. That's the open source tooling we are developing in my team. It's production ready, and as you see, it's nice for how it integrates things. It's an opinionated framework, and it will not expose all the Kubernetes functionality. You should also be aware of that. But it will work very nicely, and you will avoid several issues. And that's it. We would love to hear your input of this tooling if you are interested in that. We are conducting UX research sessions, so if any one of you is interested, just contact me, and we can organize like a 1 hour or 1 hour and a half session and see what you think and what feedback you have of the tooling. And you can contact me in my email, or you can go to that Matrix channel. Besides that, at least the last part, you can have the tutorials there to create the OCI image and to deploy with Juju. And in case you are interested also in the other parts, just ping me, and I will also send them to you. And that's all.
Thank you for presentation. And what about maintaining such a solution? So is it hard to maintain from maintenance perspective? What about logging, for example, where logs are stored?
Logs, what we do for production, we're using it for our production deployments. That is, if you use Ubuntu for some of our stores, it's already using it. And what we do, it's we integrate it with cost solution, we call it, that it has Grafana, Loki, and everything, and we monitor everything from Loki in a similar way. If you look in internet, you can find it. I think it's named Cost Lite, and you will see that you will do a Juju deploy. You have to specify more information. You integrate it with the application, and you will have the Grafana dashboard. You will can access to Loki. Otherwise, you have to go manually to the containers to see the logs. The question, the solution we have is like we have also a operator for all the Grafana Loki stack, and we deploy it, and that's how we monitor it.
Very naive question. Thank you for putting all of this together, all this complicated information. My question is why is Kubernetes so complicated?
Well, let's go back in my life, not really related to the presentation. I remember deploying manually to production. I've worked in big billing systems, and to make it them scalable, and at some point it's a mess. At the end, Kubernetes let you put the things in a lot of machines, and they handle by itself. It's easy to upgrade. You can use a GitOps process. To be honest, I found it better than Ansible and having lots of scripts touching server. I think for a small deployment, probably Fly.io, if you just have your application for a few users, will be the way to go. But once it gets bigger, at some point you will hit a roadmap and you will have to go there. Clearly, it will add a burden. Every tool you put into in your way, you will have to manage it. But anyway, it's not too hard to do it. Just do install, in this case, microcades, but there are other ones, and you will have it there. If you have problems, that will be different.
You said that the first solution was bad because the Docker file wasn't production ready.
Well, it was not bad. It's just that you will have to adapt that Docker file.
Right. What if I just want an interim solution? What if I just want the Docker file to be production ready or a Kubernetes workflow?
Well, if you want that Docker file production ready, you will have to choose what things you have to put in there. You will have to run that workload, not within developer mode, but choose Unicorn or Uvicorn or whatever you want. It would be also nice that I was before in the Docker talk. It will be nice if you use a specific user instead of root. There are many things to do and many improvements. The main two ones for me are know what image you want, what software you need, and don't copy everything because at some point you will create problems, and don't run the developer mode. With that, you will go in a much better way than with that Docker file.
Well, what I'm asking is, can I use something like Juju halfway? Can I just use it to package myself a Docker image in ECR or something, and then go from there?
Yeah, you can do it, of course. It's just, you mean what are the advantages of going without that and with it?
Yeah.
I think there are three advantages of our tooling. One is that it's very easy to deploy in multiple clouds. That is not really related to this presentation. You can kind of do a Juju deploy Kubernetes in Amazon, Juju deploy Kubernetes in Google, and deploy this application here, this application there, and integrate them. Let's say you have your core solution in one place and then your main application in another. It will be quite hard to, well, it's possible, of course, you can do it. You will have to put many URLs by hand. The second advantage is the integration that we just saw. You will not, I didn't create any database in here. It was the software operators that did it. And the third advantage, well, not really related to Juju, but Rockcraft, is that we put a lot of effort in CVEs and security.
So the CVEs are part of...
Yeah, part, let's say, all the Rockcraft kind of base images are based on Ubuntu, and the compromise of my company, it's that they have, their CVs are fixed very quick, and that your base images will be very clean.
Is that based on the version of Rockcraft, or is that based on...
It's not based on most of them on Ubuntu. Clearly, it's at another layer, but it has its advantages. It's just if they suit your case.